Hello students, today we will study about grouping of cells. We learnt about resistors in series and parallel. We also learnt about capacitors in series and parallel. Suppose if I have more number of cells, then I attach them together either in series or in parallel, then what will be the effective EMF? That is what we are going to study. How the current will flow, that's what we are going to study. For example, let me take cells, right? And every cell you know very well has an internal resistance. I am taking a cell of EMF epsilon and having an internal resistance small r. I connect another cell, identical cell, series with that. This is also epsilon and it has an internal resistance R. So again let me connect another cell and with the internal resistance small r. Okay, epsilon, they are all identical. Fine. Here I have taken only 3 cells. I can have n number of cells. Okay, n number of cells. Okay. So if I have n number of cells like this, how the formula will change? Let me connect this to an external resistance, okay, capital R, and then study about it. Fine. You know very well, from positive a current will flow through, that is going to be I, and you know it will pass through the external resistance. There will be a potential across this value, and again the same current will go through so that the circuit is complete. Now first let us say, what is the total EMF? What is the total EMF? How many cells are there? N cells are there. Okay, so what is the each value? Epsilon. They are identical, so total EMF will be N into epsilon. Let us say in an ordinary torch light, you use 2 or 3 cells, you connect them all together in series, so 1.5 plus 1.5 plus 1.5, which is 4.5. That's what I have done here, N into epsilon. That is first part of it. Now, what is the total internal resistance? Let us see. What is the total internal resistance? You know they are all in series. You know that in series resistance is added up, right? So I have R plus R plus R, it goes till n numbers, so I am going to write it N into R. In series you are going to add again R plus R plus R, so n resistors are the internal resistance, so N into R. So this term is N into small r. Now, what is the external resistance in the circuit? That is external resistance, okay, resistance. That is capital R. How many ohms? That you can add as you wish. Now, what is the Ohm's law says? Ohm's law says that I is equal to V upon R. That is potential difference upon the external resistance. But when I talk about the internal resistance and EMF, the same law will become I is equal to epsilon divided by R plus R. Whenever it is EMF, then internal resistance should be taken into account. So from this formula, the current is given by I is equal to epsilon upon R plus small r. Okay, now in this case, what is the total EMF? So if I put it like this, sometime it may cause confusion in your mind. So I will just write it in like this. Current is equal to total EMF divided by total resistance. So what will happen now? Current is total EMF upon total resistance. That means internal plus external resistance we have to include. So I is equal to total EMF is how much? N epsilon divided by total resistance is R plus N into R. This is the formula which we use it to find the current when the cells are grouped together in a series way. I hope you understand this, right? This is the formula and you can use it to solve the problems. Now, from here, I move on to parallel. Suppose if the cells, same cells, again identical cells, I use the word identical cells, right? Identical cells are connected in parallel. What will be the current? Okay, let me take the one cell and the internal resistance epsilon, and this is R. Okay, now let me take another cell, internal resistance small r epsilon. Take another cell, internal resistance small r and EMF epsilon. Connect them all together. Fine. Now they are all grouped together in parallel. Now I connect this to an external resistance, capital R. You know very well, here also the current is going to come through from all of them. This is I, and it is going to go out, go back, which is going to be I. There is one very important thing here. All the cells are in parallel and they are identical. 1.5 volt means all of them are 1.5 volt. So in parallel, only one cell's EMF will be effective. What is the meaning of it? Only one cell effective. That means only the total EMF we have to take that of the only one cell, that is epsilon. But what about the internal resistance? Internal resistance, they are all in parallel. What is the formula for resistance in parallel? 1 upon R is equal to 1 upon small r plus 1 upon small r plus 1 upon small r. It's go on. Here, instead of n number of cells, we will say in parallel m number of cells are there. Just for differentiation, m in series, m in parallel. So m cells are there, so m upon r. M upon r is what? 1 upon r, so r will be small r upon thing. So I think again you may get confused with capital R. Let me put r dash is equal to r upon m. 1 upon r dash is m upon r. M cells are there, m resistors are there, so m upon r. But when they are reciprocal, you calculate, this becomes r upon m, right? So now I am going to take it and I am going to make the substitution here, and how the answer turns out to be. Let us see now. Okay, total EMF, I said to you, only one cell is effective, epsilon. Total internal resistance, R upon M. Remember, it is not M upon R, it is R upon M. Reciprocal I have taken, right? External resistance remains same, that is R only. Fine. So let me substitute the values here. Current is equal to total EMF upon total resistance. So I is equal to total EMF is epsilon upon total resistance is R plus small r upon m. It looks rather very confusing. We can simplify this. M is there in the denominator, right? So epsilon upon r plus r divided by m, we will take it. Okay, so when we take this like this, you will get the answer to be m goes up here, m epsilon upon r plus r. Wait, just a minute, let me cross check a point here. This is 1 upon r dash, m upon r dash equal to r upon m, and I have taken m as a common denominator. Yes, of course we do a mistake, a small mistake has been done, right? M will come here also, mr upon m, so it goes up, so mr up plus this. So otherwise I will write the answer here. Current is equal to m epsilon upon m capital R plus small r, and this is the formula for connecting the cells in the group which is going to be in parallel. In n cells we say in series, m cells we say in parallel. You look at the formula, I is equal to m number of cells into epsilon divided by the small number of cells into that of the capital R external resistance, and small r is alone. Okay, now we go for the last case. If I mix them up together, right, if I mix both in parallel and series, what will happen? That's what we're going to see, and this is the last discussion. I'm going to only give you the formula, right? So 1 cell internal resistance, 2 cell internal resistance, so n cells are in series. Fine. Now I take one more column. This is epsilon r, epsilon r, epsilon r. Yeah. There are so many rows are like that, right? And I take last one. So we have m rows, n cells and m rows are there, right? M rows are there, n number of cells are being grouped together, they are all identical. Then what will be the final formula? Fine. I am not going to derive this equation, I am just going to give you only the final solution, result for you. Yeah, I is equal to m cells, n cells, epsilon upon m into r plus n into small r. Yeah, this is the formula for the grouping of the cells. Dear students, do not go for derivation of this for the sake of CBSE board exam, and also in IIT or NEET examination, which is objective oriented in the main as well as in the NEET exam. So if you know this equation and you are able to do numericals based on that, that would be much better, rather than trying to derive this equation. You already derived that of a series and you derived that of the parallel, and you see this is mixed group. This is called mixed grouping. Okay, mixed grouping. Now in this mixed grouping, you can watch very carefully. MR, when was MR? When it was in parallel. NR, when was it NR? When it was in series. I got it in the denominator, and in the numerator epsilon is there. M and n I have multiplied that of the n cells and m rows are there, so I multiplied that, so total number of cells have been accounted. So I hope you understand that the concept is more important and doing some numericals is more important, and that will be better for you, right? In the next video I will teach you about potentiometer and its application. Thank you so much.